Hi everyone. We're going to look at how to do a sequence of transformations here to show that these two triangles are congruent. My recommended sequence is always try to translate first, then rotate, then reflect. If you do it in this order, you'll never need more than 3 steps if the two shapes are congruent. So first you got to figure out which of these vertices correspond. It looks like E and T are both the only obtuse angles, so those have to correspond, E with T. And looking at the rest of the shape here, it looks like D would correspond with U, and F must then correspond with S. So when we're doing this transformation, the sequence of transformations, we've got to figure out how to get D to go to U, way over here. We have to get E to go to T, and F to go to S. And as you can see here, if I just slide it, I can't get them all to match. So I'm going to first start with the translation, a slide, to get 2 to match, and then kind of go from there. So we've got different options. I can do any of these 2 together. It makes no difference. I'm going to just slide over F to S because it's kind of the shortest little slide to do. Might be the easiest one to draw in. So let's do that. So I have to always be very specific with my steps. So F needs to go to S. So my step 1 is going to be to translate F to S. Or we could say along the vector FS. And we're going to translate DEF. I probably should have said that. We're going to move which triangle? The DEF triangle from F to S. Okay, so that's step 1. So now my new triangle is here. And it might help to kind of sketch this in so you know where the new position of everything would be. It's kind of hard to do on here, but basically the new triangle is going to look, now that it's kind of slid over like that, that's our new location of everything. So F and S are locked in. I didn't draw it very well. But F and S are in the right spot. So I don't want to move that spot because I already got that spot lined up. I don't want to mess that part up. So to not mess up a single point, we use a rotation because rotations are always around a certain point. So we're going to rotate around that point S because that's the point that we want to fix. We don't want F to move. So we're going to rotate. So we're going to rotate the triangle, DEF, about or around. It means the same thing. About, we're going to call this S. Even though F is there too, S was there originally, and that's pretty clear where S is, so we're going to call it around S. And we could figure out the angle we need, or we can just say until something matches up. So we're going to rotate around S until something matches up here. So I could say until D matches up with U. I could do that. Or I could say the other way, I could say until E matches up with T. It doesn't actually make a difference. It's just going to change your last step depending on what you pick. So let's just rotate the first way. Let's rotate D to U. So we're going to rotate around S until D matches up with U, right there. So until D matches with U. That's how we know when to stop. We could, of course, measure this angle, and we could figure out how many degrees this is, and we could say the number of degrees that would be. Rotating this would be clockwise. We could definitely measure this and say, okay, that's about 150 degrees or whatever it is. You could do that. Or you could just say until this point matches with that. So if you're not sure and you don't have a protractor, you can always just use the letters that match up here. Now we've got that matched up. Our shape kind of looks like, let's see if I can sketch it here, kind of like this, where D and U are matched up, F and S are matched up, but E and T are not. So E is over here, T is over there. We got to get those to match up. If you want 2 points to not move, you want it to reflect over a line because these 2 points make a shared line, and we're going to reflect over that in order to get this to line up perfectly. So our last step is to reflect over that line that they share because these 2 points are already matched up and those 2 make that line. So we want to keep those locked in by reflecting over it. That way E flips over to T. So reflect over the line. We're going to call this line SU. Or US, same thing. I wouldn't call it DF though because we have another DF on the other side, so you don't want to mix up which is which. If we reflect over SU, that matches E to T, and we're done. Because if I do this here, let me show you that. So our first step was to slide this over, then to rotate around S until those matched up, and now we're going to flip over so that it's over this line, so that line doesn't move, so E goes to T. And we're done. We prove that these are congruent using these transformations. You don't have to say that matches this part. I just wanted to show you that part. That way you can see clearly why we're doing it. Now you might have wanted to do this a little differently. You might have wanted to take this shape right off the bat and just flip it right over there, which you can technically do. It's just hard to say what you're flipping over. What you'd have to do is actually measure the corresponding vertices, find the midpoints, and then construct the line and then reflect over that line, which I think is more complicated a little bit, because if you just stick with translate, rotate, reflect, you can get there for any sequence of transformations to prove congruence. You can always do it like this, so I recommend just stick with that because it'll work no matter what. You may not need all 3 steps, though. It might get done in less than 3.